So welcome everybody to the second part of today's presentations, the integration tips. And in this presentation, we are talking about how to integrate our devices, what are very useful information if you want to integrate them, what do you need to consider, and some more tips and tricks. Okay, so first of all, what are Enapter's products? So we have a water tank, we call it the WT 2.1. Then we have the AM Electrolyser EL 4.0 that we just talked about. We have the dryer 2.1. And additionally, we have the multi-core and we have our EMP modules for communication of other devices. But in this presentation, I would like to follow on the devices that you can see here. Because they are most relevant when we talk about integration. So just a quick overview. So the water tank is providing fresh water to the AM electrolyzer. It is possible to provide water to up to 11 electrolyzers. Then, as I said before as well, several electrolyzers can be stacked together, can be combined for a higher hydrogen output. And one dryer is able to dry the hydrogen of up to 5 electrolyzers. So this is then 5 times 500, 2,500 normal liters per hour. So, but now the question is, okay, what is before and after those devices? So where is the purified water coming from? And what to do with dried hydrogen or with the hydrogen that comes out of the electrolyzers? So let's start on the left side. So we already talked a little bit about purified water. Also, there were some questions in the chat. So what's necessary? Purified water or DI water. What is important is we have less than 20 microsiemens per centimeter. So this is the conductivity that is allowed maximum for the stack to be able to do the electrolysis. And therefore, you are usually using tap water, which you then provide to a water purification system. And those water purification systems, they have different filters and mechanisms to filter dust, particles, and ions. And some of these WPS water purification systems, they also have a conductivity sensor. And this helps to ensure a high filtration. But please keep in mind to regularly maintain your water purification system so that we always have a steady and high quality of the purified water. So what's necessary to consider here? So if you are able to provide several filters and pre-filter, so to say, the water that comes out of the tap, that's definitely an advantage. Because additional filter steps, they just make sure that the overall maintenance is then easier. So you have to imagine if you have several filters, so from very huge filters to very fine filters, then in every step you are filtering more and more particles and ions out, and the result is that the the expensive filters or the very fine filters, they are not getting used up as quick as they would be without additional filters. So for example, if you have a water softener to filter magnesium and calcium, that would extend the lifetime of your WPS. Then second step, the water purification system. So as I said, some of them have a conductivity sensor, so that is very useful. And whenever you see a warning to change the cartridges, then do that as soon as possible so that the water quality is not suffering. The water purification system is then connected to your water tank module, and the water tank module has a conductivity sensor also at the input, but of course if it detects water with a high conductivity, then yeah, it might be already too late. So if you are providing bad water to the water tank and the valve at the water tank cannot close immediately, then you will have to clean up your water tank to purge it to just make sure that you have always a high water quality. Usually for the water purification system, as well as for the water tank, you can use standard plastic pipes. They are widely available. So I think there is not so much to say about those. We will go then more in detail when we talk about the other pipes and connections. A small crash course about the pH value versus the conductivity. So because very often customers are asking us, okay, conductivity, okay, but can I also measure the pH value? How is it related to each other? How is it working? So what needs to be considered is the conductivity is usually better to measure because it is more precise. So as the pH value is is a logarithmic value which is increasing. If it increases by one value, it means that the conductivity is exponentially growing. So that's why it's usually better to measure the conductivity, because then you have a better picture of the water quality. And what I also want to show you here on the graph in the middle is that so this is the input quality of the water versus the output quality of the water regarding the conductivity. So if the cartridges of the water purification system become older and older and they absorb more and more ions, then there will be sooner or later the moment when the conductivity is raising very, very quickly. So we have a very, very slight increase in the beginning, but then the conductivity starts rising very quickly until the point where actually the outlet water quality is even worse than the inlet water quality. I hope that we will never reach this point, because when we see the values that we have here and 20 microsiemens per centimeter, they're somehow here. So, but what I want to say is that as soon as the curve starts to raise, we need to be careful. So, because then it might go very quickly, and of course we want to avoid that. So let's talk a little bit more about the water tank, so that you know what are the interfaces of these devices and how to connect them to the other systems. So in the top of the device, you have the H2 out. So this is where the water from the water tank is provided to the electrolyzers. Then, of course, you have an H2O in port. So here you will attach your water purification system. And then you have a few more ports, for example, the overfill. This is just to prevent that, the water is, so to say, blowing up the water tank. So in case there is too much water in, it will just be released by the overfill. Then there is the maintenance port. So if you are purging the water tank to make sure that you have the right quality of water, then via this maintenance port, water is released. And then you have the depressurization port and the drain port. So those are also there to get rid of water, either in overpressure, or when you want to empty the water tank, then you can release the water via the drain port. So I also brought you some more pictures here. So this is the full chain. So purified water comes to the water tank and then further to the electrolyzer and the dryer. So what's the advantages of the water tank? We have very low maintenance. So yeah, you can just drain and fill the tank if the water quality is not matching the purity requirements. But in a normal operation, this should be fine. Then you have the remote monitoring and control, the same as you have it in the electrolyzers, and it can provide water to up to 11 electrolyzers in parallel. So here we also have PNID, where you can see the principle. So H2O is coming in. We have a conductivity sensor to measure the conductivity. If it is fine, then the valve opens and allows the water to enter the water tank. And then from there, it is going it is pumped out through the H2O out to the electrolyzers. And here you can see the other ports that we were talking about: maintenance, overfill, and drain, as well as depressurization. So some tips and tricks regarding the water tank. So yeah, make sure to provide only water with the right quality to avoid any maintenance rinsing. So yeah, this is what I was already focusing a few times. Yeah, water quality is very important. Unfortunately, we see that from time to time that customers are exchanging the cartridges too late, or yeah, ignoring any warnings. So this is not good. Please take them serious and make sure that the water quality is always fine. Depressurization line, drain, maintenance, and overfill, they can basically be led to the same sewer, so that's not a problem. You can combine them together. Yeah, because usually if the system works fine, then you will not have any water there. But just in case, you don't need to separate them. It's the same water, and no need to separate them. Drain and refill the water tank completely if it has not been used for several weeks. So yeah, the water inside the tank should be kept circling. So if you're producing hydrogen and you're using your water tank regularly, that's totally fine. But if you are not using your water tank for several weeks, I don't know, because you're building up a new hydrogen site or changing your setup whatsoever, then just drain the water tank, because yeah, the water inside will not get better with the time. Yeah, then regarding the H2O in, connect the T-piece to the H2O in line to be able to get rid of the first milliliters after the water purification system start, because the water purification system, when it didn't work for a while, then some of the ions, they just remain in the pipes, and yeah, you don't want to have them in your water tank. So just make sure to get rid of the first few milliliters and then start the filling process. If the WPS contains a conductivity sensor, then yeah, you're able to provide the water to the electrolyzers directly. You might not need a water tank. That depends on your individual setup and also, of course, of the performance of your water purification system. Okay, the electrolyzer. Yeah, we already talked about it. So we have different ports here: H2O in, O2 vent, H2 out, H2 vent, and the fill drain port to fill up the electrolyte. Yeah, I want to keep it a little bit shorter because we already talked about that in the previous presentation. So, but you have a low maintenance, you have remote monitoring and control, you have a very efficient device, and yeah, it also automatically stops the hydrogen production when it reaches the 35 bar maximum pressure, or the 8 bar if you are having a Korean or Japanese version of the electrolyzer. So yeah, that works completely automatically. And then once the pressure drops to a specific threshold, then it also will restart the production. Of course, you can change that all depending on your individual setup. Also, the pressures are adjustable, of course. Yeah, so here again, for those who couldn't attend the first presentation, just a quick review. So H2O is coming in through the H2O import, is then flowing into the electrolyte tank. The electrolyte tank contains the electrolyte, which is then pumped through the heat exchanger and the AEM stack. So we have a circle here, and oxygen is then released by the O2 vent line. At the same time, you have hydrogen produced in the AEM stack, which is then released by the H2 out. And you have an H2 vent line, which is there to get rid of water vapor, because the hydrogen is already purified right inside the electrolyzer to reach the 99.9% of purity. Tips and tricks. So provide water with very low conductivity. We already had that. Do not connect the O2 vent line of the EL 4.0 with older models. I also talked about that in the previous presentation. The recombiner, which is now part of the EL 4.0, makes the oxygen vent line be line with very hot oxygen. So we're talking about up to 200 degrees hot oxygen, and this is not possible to combine with the previous models. Often also there are used plastic pipes, and of course they are not compatible. Then use an appropriate sized buffer tank for the electrolyzer to reduce this frequent on and off cycling. We also talked that in the previous presentation a bit in the question and answers. So a buffer tank makes sense if you don't have a big tank anyway. So if you are attaching a fuel cell or a compressor or something like that, then a buffer tank really helps to reduce the amount of starts and stops, and increases the overall lifetime of the electrolyzer. So that's very useful. Then let's also talk about the H2 vent. So do not obstruct it. Always keep it to atmospheric pressure. We're always saying like it needs to breathe. Yeah. So on the one hand, it needs to be able to push out the hydrogen with the water vapor, but on the other hand, it also needs to be able to suck in a little bit of air, so that when you switch off the device is able to go back to atmospheric pressure, because we don't want that the system remains under pressure when it is switched off. Then, if you want to drain the electrolyte and you want to exchange it, for example, during maintenance, so once per year you need to exchange the electrolyte, then you do that via the fill drain port. And if you lifting the electrolyte back, then the electrolyte will flow into this port. So make sure to always keep the electrolyte bag above the upper edge of the device, because that is just working with gravity. So the electrolyte can only flow in if you place the electrolyte bag above the electrolyzer. Okay, then let's talk about the dryer. We have here the H2O import. So here the comparably wet hydrogen, or the hydrogen with the 99.9% purity from the electrolyzer, comes in, or from several electrolyzers, also possible. I said up to 5 electrolyzers are possible. And then here H2 out, this is where the dried hydrogen comes out. So after the dryer, the hydrogen reaches a quality of 99.999%. So very, very pure hydrogen. And this is then also suitable for most of the fuel cells and the devices that at least I heard so far in my hydrogen career. Then the purge line, as I said before in the previous presentation, the H2 vent line of the electrolyzers can be combined with the H2 purge lines of older electrolyzers, but also with the H2 purge line of the dryer. So yeah, you can put them together. Of course, make sure that you have appropriate sizing of your pipes. Yeah, that's very important. And then they can be combined. That's not a problem. Here again, you can see the chain. So from water tank to electrolyzer to dryer. What's the advantage of the dryer? We have a maintenance-free device. Basically maintenance-free. The only thing you need to do is make sure that the meshes in the front and in the back of the device are clean, that there is no dirt, no dust, I don't know, no other bigger particles accumulating there. So to have a proper cooling power. The dryer itself is self-generating, so it can continuously dry hydrogen. So even if you are producing 24/7, it is possible to always have dry hydrogen. It doesn't need to be switched off for regenerating. It is very efficient, and it also supports this full automatic hydrogen production, where I said before in the electrolyzer, when you reach the maximum pressure, it also automatically switches to standby, and you have the possibility to fully monitor and control the device via app and web interface and Modbus TCP/IP via the dryer control network. So this is a software solution that we implemented when you are having a dryer and you have this combined with 5 electrolyzers, for example. Then you can set up a dryer control network and then be able to control and send commands to these devices just once, and they will all follow the same command. How does the dryer look from the inside? So the hydrogen from the electrolyzer is coming in, then it is split up. So either it's going to the cartridge 0 or the cartridge 1. They're doing the same, but this double system allows a continuous drying of the hydrogen, so to say. And then the hydrogen goes out here to the H2 output, and then the water which has been extracted in these cartridges, it is released via the H2 vent port. And yeah, so depending which cartridge is active, which one is drying, the valves are opening or closing, so that you have this continuous drying process. Quick information about the depressurization line. So this is only used in case that there is some overpressure inside the system that cannot be released due to some strange failure. Then you still have the possibility to depressurize the device via this port. But yeah, in most of the cases, just keep it closed. You don't need it, and if you need it, we will tell you. So don't worry about this port, just keep it closed. You don't need to attach it to some other pipes. Tips and tricks. So there is no check valve necessary downstream the H2 out. So yeah, an internal check valve is avoiding that the hydrogen is flowing back from your tank or from your fuel cell or whatever you have attached. So yeah, you don't need to worry that you will lose any hydrogen that you already produced. That's not a problem. Then regarding the purge line, it is releasing water steam and small amounts of hydrogen. So yeah, make sure to lead them to atmosphere and be aware that they contain hydrogen. So yeah, take it seriously. Don't connect them to oxygen pipes, and yeah, keep them away of the outlets of the oxygen outlets from the electrolyzer, for example. Yeah. You can connect the purge line of the dryer to the purge line of the electrolyzer. This is what I already said before. Make sure that the piping diameters are correct. Of course, this is not only applying to the purge line, also to the H2 lines, so all your hydrogen lines, to your oxygen lines, of course, and of course to your cooling lines. All the pipes, of course, need to be dimensioned appropriately. Then The depressurization line, as I also said, you can open it before transport to make sure that the system is really depressurized. But during normal operation, please always keep it closed and make sure that there is no hydrogen escaping via this port. Another thing regarding the position of the dryer. So generally, you can mount it below the electrolyzers. This has the advantage that if you imagine that the hydrogen is coming in here and it is coming from the top, then due to gravity, the water, which will maybe condensate a little bit inside the pipes. Of course, this is not a lot of water, but if we're talking about several weeks or months of operation, then there might be some water accumulating inside the pipe. And this is not a problem if the dryer is in the lowest position, because then the water is just absorbed and is not sticking inside the pipes, which in the other way around, if the dryer is in the top position and the hydrogen is coming from a lower position, then yeah, it may be possible that the water is sticking in the electrolyzer output, and we want to avoid that. Okay, now quickly about the hydrogen output. So yeah, as I said, we can use buffer tanks to store the hydrogen. You can also attach a gas boiler or a compressor fuel cell. You are very flexible with that depending on your setup. Also, different devices need different purities. So make sure to read the requirements of your attached devices. Let's quickly talk about compressors. So if you're using a compressor to further compress the hydrogen, then make sure that you have a continuous production. Therefore, it's definitely recommended to have a buffer tank, so that the amount of hydrogen which is, so to say, used by the compressor is produced at the same time from the electrolyzer, so that it's balanced out. This will this is better for the AAM stack and will increase the overall lifetime. Regarding the fuel cells, so yeah, with the dryer 2.1, you have the possibility to reach 99.999% purity, which is sufficient for the fuel cells. And yeah, also for those, it might be recommended to use a buffer type, but yeah, this is not something that can be generally answered. Always depends on your individual setup. And yeah, the same for the compressors. For all the external devices, you can also connect them with our EMP modules to be part of the Enapter management system. So you can then also look up their values in the web browser and see, okay, what's the current pressure, what's the consumption, and so on and so forth. For PV cells, for fuel cells, for all kind of hydrogen equipment. Okay, that's it. Thank you very much for your attention. We are already a little bit late. I was talking too much, I think. But yeah, maybe we have the possibility to answer some questions anyway. Hi, Stefan. Maybe you can read out some questions for me from the chat, if there are some.
Absolutely, Philip. So first of all, thanks for the presentation. It looks like you did a great job on explaining, because the amount of questions decreased a lot. So thanks for doing so. Looking to the time, I would say we just go for 1 or 2 questions and then we move over to the next presentation. So there's a question on documentation availability. Heiko especially is asking if all of that is available in German already, and if we could give that out as a handout, so just to make it available for customers while they're on site installing things.
Yeah, very good question. Actually, we don't have the documentation in German yet, but this is something that we are working on. So in the meanwhile, we are having customers from all around the world, and of course, we want to make sure that everybody understands the documentation and is able to integrate the devices. So currently we don't have it, but yeah, we will inform you if this documentation is available. And until then, please feel free to just contact us whenever you have questions. We are willing to answer, and we hope to always help you out, also in German.
Okay, thanks a lot. And then there's a question from Thomas. He's asking if the new product, the EL 4.0, is ATEX certified. And the same question is for the sensor inside the unit.
Yeah, that's actually a good question. So the electrolyzer is not creating an ATEX atmosphere, but still it must not be installed in an ATEX environment. Yeah. So did I say that correctly? I think I got a bit confused now. So yeah, generally the devices, they are leak tight, so we don't have a continuous hydrogen leakage rate like you may know it from other electrolyzer manufacturers. But yeah, make sure that there are no open flames and or sparks or something inside the or close to the unit inside the same room, because we're still handling hydrogen here, and as we heard it yesterday, hydrogen is yeah, easy to ignite, and we want to avoid that, of course.
Okay, thanks for that. So looking to the rest of the question, it seems they repeat a bit, so we take them to the end of all the sessions today to get some answers. And that would bring us to our next presenter. So Philip, thanks for doing your presentation. And now we are going to move over to Max, and he will tell us about the journey of deploying all the Enapter devices.
Thank you very much. And yeah, looking forward to Max's presentation. Thank you.